Toby is asking that the class should be recorded.
Okay, I think the recording is on.
Okay, all right. Okay, no problem. Yeah, I just noticed that. All right,
We
you
just
can create
like,
schema RDGs for external class. I said that. So let's go to the next slide and then we move. Okay, so to include Spark SQL in your application, you will need
Falcon,
some
please
addition.
help minimize the screen pop-up.
Okay, all right. Let me.
Thank you,
Thank you.
sir.
To include Spark SQL in your application, you would need some additional dependencies, as is the case with other Spark libraries, as this enables building the Spark core without relying on external additional packages. So what is happening, what this means is that to run Spark SQL in your Spark application, you would need some additional dependencies, more like something like could be related to Maven, where we or the external classes that we add in our Java project usually. So because SQL is not inbuilt, one thing you can do is either you actually download more like or download an SQL server on it, SQL application on it, or instead of having an SQL application itself, you can actually just there are some Spark libraries that actually have this SQL capacity or capability. So you need to add them to your Spark environment before you can run Spark SQL in your program. So you can build Spark SQL with or without the Hadoop SQL engine, just like I said. So you might not, you could use it with the SQL engine on Hadoop, which is Hive, or you can actually not use it. Remember that Spark, remember we always said that Spark does not necessarily depend on the Hadoop system. It does not really need Yarn to work. It does not really need Hive to run SQL. If you remember, I think when we started with Spark, we talked about how Spark can run or has its own clustering system that could actually cluster or manage the clusters without the need of yarn. So you could also run it on yarn if you want, but there's also the option of running it without yarn. Same thing happens with the SQL case. You don't necessarily need the SQL engine on Hadoop, which is Hive. You can actually use it without Hive. So, however, Spark SQL has Hive support to enable access to all of these Hive tables, user-defined functions, the all these formats on that's the saving formats, serialization, and the serialization formats that used to save files on Hive, and then Hive query language as well, which is the QL, the query language format. So to use Hive libraries does not need you to install Hive here. So download of Spark in binary form already has Hive support built in, and including Hive support is a great idea for building Spark SQL programs. So depending on whether Hive support is required, programming against Spark SQL can have two entry points. So just like how, if you remember when we talked about when we did programming with Spark, when Marvelous was taking us, we mentioned something like Spark context, which is like the entry point for Spark programs that you use to call various methods, more like the case of when he compared it with the pandas in Python, where he said you have import pandas as PD and then you're using PD dot something something. So over here too, you have the context that you also use to write Spark SQL languages. So you have the Hive context that is to provide access to Hive QL and other Hive dependent functionalities. And then you have SQL context, which includes a subset of the Spark SQL support, which does not depend on Hive, in case you have conflicts with including all of the Hive dependencies. So it's possible you might have some issues including all the Hive dependencies, or your system might not, there could be some problem. So instead of using Hive context, you can as well just opt for the SQL context. So for working with Spark SQL, HiveQL is the suggested query language. Spark SQL in this Spark 1.0 and 1.1 is based on Hive 0.12, and then okay, this is just dependencies on what they are based on. So in essence, Spark already has the SQL inbuilt, but you could as well use the Hive dependencies as well with it to run your SQL queries. So connecting to an external Hive installation. So this is if you want to use it with a Hive installation on your system. That's more like you want to use it with Hive from your Hadoop. So to connect Spark SQL to an existing Hive installation, you copy your Hive site.xml file to Spark's configuration directory. So this is what you'll be doing this in your terminal. This is a directory that exists with Spark. So you copy that Hive site XML file to that configuration directory. So once it gets there, it's more like it's introduce the capability or the Hive capacities to your Spark SQL system or your Spark core. So in case you don't have an existing Hive installation, so that's if Hive is not installed on your system by chance, that's probably you don't want to use Hive from Hadoop. Spark SQL will create its own Hive metastore, metadata DB in your program's work directory called metastore DB. So when you create tables with the Hive QL create table statement, they will be placed in the user/hive/warehouse directory on your default file system, which may be your local system or HDFS in case you use an high HDFS disk. So this is how when you create tables with your Hive QL statement, so they are being saved in your local file system. It could be HDFS if you are using it on HDFS. Remember that it's not compulsory that Spark must be used on HDFS. You could also use it on a local file system. So same thing happens. So whichever one you are using in the case, you can save the table is going to be created on that one. So applications with Spark SQL. You can use Spark SQL in a Spark application and to load data and to query it with SQL and also combine it with your program code in Python. So for this, construct a Hive context or SQL context based on the Spark context. Okay, so you create what's happening here is that you are constructing the Hive and SQL context based on the Spark context that already exists for every Spark application. So if you have a Spark application, you want to run SQL, so you are going to construct this Hive context. So this context will enable functions for querying and working with the Spark SQL data. You can build schema RDDs using the Hive context. You can operate on the schema RDDs as representative of structured data and use SQL or with normal RDD operations like map. Yeah, so exactly that's that. Next slide. So loading data and executing queries return schema RDD. So as you know, remember that when you run your SQL produces structured data. So even if you run execute your queries by chance on an RDD that is possible, and then or you run it on a schema RDD, what's going to be returned in essence is going to be a schema RDD, that's a structured resilient distributed data set. So it said it is similar to tables in a regular database. Basically, a schema RDD is an RDD which consists of row objects along with schema information of the types in each column. So it's more like having more like column heads. That's what the schema information is saying. They're more like the fields that indicate what information is being contained in each column. So row objects are wrappers around arrays of basic types. So e.g. integers and strings. So that's what these are just objects that could exist in a particular row. I mean, we all know what a row is. It's just a straight horizontal set of data. So it could be integers, it could be strings as well. So while you can also work schema RDDs as with regular RDDs, using existing RDD transformations like map and filter. Sorry. Using existing RDD transformations like map and filter, schema RDDs have additional capabilities. Okay, a schema RDD can be registered like a temporary table so that it can be queried with Hive context.sql or SQL context index.sql. You have already seen in listing above. Okay, so the thing is, I noticed that over time there are some things in the slides that are sort of missed out from, or more like they just copy the slides by just copying sentences from the textbook. So there's a particular listing that's supposed to be there, but it's not here presently. So it's not in the slide. I don't think it's there. Let me check the next slide. Okay, it's not there. So um so we can't see it here. But then I'll just continue. It's in the textbook actually. So as you can see, you have already seen listing above how this can be done using the register temp table. So it's more like a function. Probably we'll see that in our lab when we get to the lab. So we can't see that in this slide now because it wasn't put in. There are many cases like that I've noticed so far. So yeah, so that's just simply used to, it's more like it's more like an SQL query that is used on a table to register it to your Spark. More like, so it's telling Spark to create that table as an RDD and store it in memory. In essence, so schema RDDs can store the following basic types and also arrays and structures of these types. Okay, so all these are what was here. The another table that is here too that is supposed to be here actually, but they are not. It's not showing. It's not in the slide the same way. So what's supposed to be there is more like a list of data types that could be that schema RDDs could contain. Here we have um, okay, let me just read what it says. HiveQL syntax cannot be used to define them. All types can be nested within each other. So what we have here, we have just a table of data types for Spark SQL, look, Hive SQL type. We have tiny int, small int, big int, float, double, and then we also have the scalar types and we have Java types as well. So all these types are nested are the types of data you can have in schema RDDs, and schema RDDs can also contain arrays and structures of these types. So in essence, I'll just go to the next slide. The question on the next slide will only be answered with that table. So the only way you can answer this question is if you see the table, but the answer to this question clearly is, the answer is which of the following is not a scalar data type that can be stored by schema RDD? So byte can be stored, long can be stored, and map can be stored. It's binary that is not a scalar data type. So, but because the table is not present here, so you might not be able to relate. So the answer to the question is binary actually. So I'll go on. Sorry, I hope I'm not speaking to myself. Are we there?
Yes, sir. Please go on.
Okay, all right. So record. So using row objects. So these rows that you have in schema RDDs, how you use them eventually, and how you call queries on them. So records within schema RDDs are represented using row objects. They are fixed length arrays of fields. So just like as I said before, schema RDDs are more like they are ordered. So if you have a row, it has a fixed length, more like an array, and it has a fixed length of elements that are inside based on the number of columns. Just look at it in that way, based on the number of columns of your table. So one row has a fixed length of elements that are in the row. So it says a fixed length arrays of fields. So in Scala or Java, row objects have getter functions to get the value of each field given its index. So yeah, it's getter functions are just what you see when someone is writing a code and you see something like get string or get something. So that's what getter functions mean. And the usual getter is get in Java and apply in Scala. So get in Java, apply in Scala. So if the getter function in Java is get, the getter function in Scala is apply. So most likely in Scala you will see something like apply string, while in Java you are seeing get string. So this takes a column number and returns an object type in Java and any in Scala. So just like how you have a row, remember a row, like I said before, and it has a fixed number of elements based on the number of columns that exist in the table. So if you use that analogy as well, you can see that if you specify the number of a column, it will also specify the number of the elements in a particular row, which is like an array. That row is like an array. So specify the number of a column, it specifies the number of a particular object in that particular column. So it takes the column number and returns an object type in Java and scalar, and then in scalar. So we need to cast this to the correct type. So what this is saying is that when you are calling an element, or when you want to return the object type and you're calling the number of the column, you need to cast the correct type of the object that exists in that particular column of that row object. So for instance, you cannot be calling, let me say, the object there is a name, for instance, like a name like Adeto. So you now say get int. Obviously, a name Adeto cannot be returned as an int, so you won't use that. So the best way to go about it for that case is to say get string, then the column number where Adeto exists, so it presents Adeto as expected. So Boolean, byte, double, float, int, long, short, and string has a get. So here get, the type there is just a generic symbol. Type is meaning you can replace it with different data types that you have. So it could be get Boolean, get byte, get double, get float, get int, get long, here with the parentheses following method which returns that type. So thus get string 0 would return field 0 as a string. So yeah, I hope that's understandable based on what I've said. So hello, is someone about to say something? So if we remember yesterday, we looked at catching as well, which is a means of persistence and sort of fault tolerance with Spark. So Spark stores data efficiently by two means of catching, by retaining the um, the past records of previous jobs in memory to be used for other jobs eventually. So what is being said is what you call cache, and yeah, so here we have caching in Spark SQL as well. So as you have here, Spark can store data quite efficiently as we know the types of each column. Rather than using full objects, use of the Hive. Now this Hive CTX you can see here is the Hive context. That's the Hive context keyword. Just like how you have the Spark context keyword from yesterday as we wrote SC. So this Hive CTX here is Hive context keyword, and then it's Hive context dot cache table, and then the table name method is recommended as allows cache using memory efficient representation. So in essence, so what's happening here is that you're saving the table in memory in sort of a more like a compressed format. So it manages memory and then it helps for efficient representation. Typically, Spark SQL will represent the data in an in-memory columnar format while caching a table. The table remains in memory as long as the driver program is alive and if it exists. And if it exists, the data needs to be reached. So the Java program here is just the program you create and that you're going to run eventually for when you're running your SQL. So the tables can be caged while running multiple tasks or queries against the same data. The table can be caged while running multiple tasks or queries against the same data, exactly just like I said. So as you run a particular job on or a particular query or whatsoever you're doing on a particular data set, it stores the results in memory and be caged that way, and then keep running multiple tasks and all and all. So this is just a means of improving performance that Spark has implemented. So HiveQL slash SQL statements can also be used to cache tables. Okay, very good. So you have cache table, table name, and then on cache table this. So these are SQL statements that could be used to cache a table. As you can see, it follows the normal SQL format. Cache table name. We all know that. You can see the cache schema RDDs in a Spark application UI. So yeah, so if you have a more like the Spark application, you can see maybe you have a GUI or something. So you can see just like how your MySQL workbench, you see your schemas and all around. So you can also see the cage schema how it is in the UI of the Spark application. So yeah, loading and saving data, loading and saving data, loading and saving data. So in Spark SQL, you can get raw objects from many unstructured data sources such as Hive, tables, JSON, and Packet files. Yeah, I think perfect packet files. I don't know how well. I think I've left the meaning has left my head right now. So I think perfect packet files is just, I think is more like a saving a file format that contains a lot of information. I can't remember. I guess I'll probably check that later, but I can't remember. Just keep. So you can also query these with SQL and choose a subset of the field. So yeah, Spark SQL will scan just the required subset of the data for those fields, unlike a naive Spark. That's supposed to be naive. Sorry, unlike a naive Spark context.hadoop file. All right, I'll just try to make reference to the textbook because I know at times there are, so like I said before, there are things that always don't merge. So what's happening here is that it's saying although these are unstructured data sources, like you can see here, Hive tables, JSON files. I mean, we all know what JSON is, right? Can I ask somebody? Call a friend. Can you guys hear me? Hello.
Yes, I can hear. I'm
Okay.
with you.
Very good. Very good. Thank you very much.
Yeah.
So all these are unstructured data sets. They contain information that is not structured. So however, you can query them with SQL, and while you want to query them, you have to load them to the SQL platform, and you can actually choose a subset, or you can see there a subset. So a part of the file, maybe a part of the fields that maybe are sort of structured in some way. So you could actually choose that aspect, and Spark SQL will scan that required aspect you chose, and you take it all and then use it to to run or to do what to do, run the queries that you intend to run on the data set. So it is also possible to transform regular RDDs to schema RDDs in a program by assigning them a schema. So just like I said before, regular RDDs are more like unstructured. They don't have schema, they don't have patterns. So you can also transform them to schema RDDs by assigning them a schema, thus enabling writing SQL queries even when data is Python or Java objects. So SQL queries are compact, even if we work on many quantities simultaneously. SQL queries are compact, even if we work on many quantities simultaneously. So what he's saying here is that SQL queries are more compact and they are not so large and all like that. So even if you are working on many large quantities of data, so the queries you have is just very compact. I mean, we've had experience with that with all our MySQL assignments, and I guess that's what it means. So, and allow joining RDDs with schema RDDs from other Spark SQL data sources. So yeah, that's the end of this slide. And is there any question so far? Can I ask Mr. Edward?
I like that bailout. No wala. Ask Mr. Edward. Okay. Okay. No wala. I will be there to answer the question if there's any.
Right.
All right.
But I appreciate that you're here today. So I'll just close this and then okay. So yeah, loading and saving data. So you can load and save data through these means. You can load and save data with Apache Hive, which is Hive, as you know. So Spark SQL can support all Hive supported storage formats, which I mentioned before, the serializing and deserializing format, as you can see there. SADIS. I think Mr. Edward taught us this when we were in Hive. So such as text files, RC files, ORC, the packets, Avro, and protocol buffers while loading data from Hive. Okay, so or why you can load data from Hive to Spark SQL to use it, and it supports all these storage formats, so it's not really a problem for you to, or something that you have to bother about. Unlike maybe when you want to load um, a text file, you can't put it on something like Excel, or maybe or you can't send the text file to MySQL. So Spark SQL beats that and supports all these different storage formats. So with JSON, Spark SQL can infer a JSON file efficiently with records fitting the same schema by scanning the file and allowing access of fields by name. Yeah, so that's another wonderful ability of Spark SQL. So with RDDs, you can create a schema RDD from an RDD. So in RDD, in Scalar, RDD with case classes are implicitly converted into schema RDDs. So let me see. I don't know if the snippet, there's a particular code snippet here that is supposed to indicate this. Okay, it's not here, but basically, if you what is here is you have more like you create classes in your Java, and you have a class that is created with the case classes. So those case classes are implicitly converted into schema RDD, because as you run the case class, you specify fields that fields for the data set you have in the RDD. So yeah, that's so you can also load. Okay, you can also connect Spark SQL to some other applications using JDBC um, and ODBC server. Sorry, can someone tell me the meaning of DBC? Anybody? Sorry, is anybody with me? I need the meaning of JDBC.
What did you say? What did you say again?
I said I need the meaning of JDBC or ODBC.
The meaning? Oh, I think JDBC is Java Database Component. I don't know. That's what I'm guessing.
Connectivity.
Yes, connect. Okay,
Yeah, that's
connectivity.
wonderful.
But
You
the
guys, you guys
ODBC, I'm
have
not sure what the O means.
I guess Mr. Edward is proud of each and everything.
O means the open.
Oh yeah, ODBC, yeah, Open Database Connectivity. Yeah, so yeah, thank you very much. I appreciate that. So Spark SQL allows JDBC connectivity with which business intelligence tools can be linked to a Spark cluster, or a cluster can be shared across multiple users. So basically, the JDBC connectivity helps to link business intelligence tools, more like Power BI, for instance, to Spark SQL, so that the data sets could be shared and queries could also be run interchangeably, I guess. So the JDBC server runs as a standalone Spark driver program shared by various clients. The cluster resources and cache data is shared among all clients, and each client is able to cache tables in memory, query them, etc. So what this is saying, I suppose, is if you have maybe an organization and you can have many clients that have access to this server and could also reach out to data in the cluster and run queries on them, use them for whatever they want to use them to do on that particular on the server, the JDBC server. So the cache data is there present in memory and they can always have access to it. So Spark built with Hive support is needed for JDBC server. So unlike the case where we mentioned before that your Spark could probably not have Hive support. However, for you to use JDBC server, you have to have Hive support for that. So Spark SQL's JDBC server corresponds to the Hive server 2 in Hive as it implements Thrift Communication Protocol. It's also called the Thrift server. The server can be launched, that's in your terminal, with that particular line of code. So start server.sh, that's if you're in Spark directory. So proceeding, working with Beeline. So you can use HiveQL commands to create list and query tables in a Beeline client. Beeline is a client that I believe it's more like a different and more like an application on its own, something that you could also use to create and query tables. I'm not so sure, but I believe Mr. Edward is always here to help us. So to create a table from local data, create table, okay, load data. Yeah, those are the queries you use to create a table and to load the data into your Beeline. Hive supports loading text files, including those they fix delimiter such as CSV. There's a mistake, that should be such delimiter some. I guess it should be such. The Beeline shell allows fast data exploration on caged tables shared by multiple users. You can write SQL to query the data. Okay, so long-lived. Okay, if you go through the textbook, there's also a query list that exists here that shows how to call, how to create and load data into your Beeline, but I don't know. So I'll just proceed. So long-lived tables and queries. By registering a cage table and running the cage command on it, you can share cage tables between multiple users with Spark SQL JDBC server, as the JDBC Thrift server is a single driver program. So by registering a cage table and running the cage command on it, you can share cage table between multiple users. So if you register a cage table on your server, the JDBC server, and yeah, you run the cage command on it, so you make it available for multiple users, so you can share it via the server and they can all use it together. Okay, how are business intelligence tools typically connected to Spark SQL? I mean, this one is simple, right? So the answer to this is JDBC, as we've just gone through now. So JDBC, yeah. So next thing we have on our agenda, user-defined functions. Remember when we are in Hive, we talked about user-defined functions, and in the same way in Scalar, we could also have user-defined functions that we define to enable us to run or to increase the capabilities or increase the scope of queries we can actually run on our data set. So we are not limited to just queries that are defined naturally or defined with Jesus Christ, what happened? Okay, sorry, I don't know what's going on with my about that. So okay, like I said, it doesn't limit you to the queries that are inbuilt with your Spark SQL. You can define some functions for yourself and run them as queries on your tables or your data set. So just like we remember with Hive, we said we could do that with Java, we will also do that with other programming languages too. The same thing happens here. You can register custom functions in Python, Scala, and Java with the help of user-defined functions and call within SQL. This enables advanced functionality to SQL users who can call into it without writing code. You can use Spark SQL to write UDFs as it supports its own UDF interface as well as existing Apache Hive UDF. Spark SQL, UDF. Spark SQL has an inbuilt method to register UDFs by passing in a function in the following manner in various languages. Note that UDFs work on multiple types. Note that UDF works on multiple types and can return a different type than the one called with. So basically what this is saying is just if you follow it, it's just saying that you could run UDF on different data types and you could return a data type that is different from the one it is called with. So I mean that's not particularly, let's say, new. You get, I mean, we know that with Python, we know that with, if you use Python, we use probably R. So basically you could run your function with some different data types of your argument, and then you could also return a different data type entirely. So in Scala and Python, the native function and lambda syntax. So basically what we can use in Scala and Python to define defined function is the Scala native function, and I don't know what lambda means really. I didn't really see something like that. So the return type needs to be specified using a schema RDD type. Okay. So in Java, extend the appropriate UDF class. The return types can be found in org ... and this is just like a module that you import when you're using. And in Python, we import the data type. Okay. So now basically what Java is saying is you extend the appropriate UDF class. So if you have a class that has been created before that contains the function, so that contains all the particular lines of code that you want to run in your query. So you've created a class separately somewhere. So where you now want to call the function, when you now want to define the real user defined function you want to use, will now be in your main driver class. So you now extend the class you've created previously inside that main driver class. So extending is more or less the way you extend in Java. You just call the class again inside another class and specify what is going to return eventually. So that's some Java concept. So Hive UDFs, regular Hive UDFs are already included in Spark SQL by default. In case of custom UDF, you need to ensure the jars for the UDF are included in the application. Yeah, so these are custom UDFs, so the ones that come with the system. So you need to ensure the jars are always available, because if not, it won't run. So while running the JDBC server, this can be added with the jars command line flag. Okay, use the Hive context instead of SQL context while using Hive UDF. Okay, so as you can see the last is to make a Hive UDF available, you need to call Hive create temporary. Okay, remember when we did our lab with Timilola to create the function you will eventually run on your SQL after creating the previous class with its function in that class. So you now come to your terminal or where you want to run the eventual code. Then you now write create temporary function name as, and then the name of the function as the class you created before dot the function you created previously. So before that, you use the Hive context to call it Hive ctx dot SQL. So yeah, that's just differing scenario here for Spark compared to Hive. So Spark SQL performance with higher level query language and additional type information, Spark SQL is efficient and can be used to perform conditional aggregate operations such as counting the sum of many columns without needing to construct special objects. Okay, I don't know how this implies really. I try to understand it from different ways, but I think it's the same thing that happens with our normal MySQL. I mean, you can actually run aggregate functions without specifying the eventual name you want to name the aggregate function. I think that's what he's talking about, but maybe I've not understood that. Probably Mr. Edward will put us through on that after now. And so group by, yeah, these are just lines of code that you use to just similar to MySQL that we know. So Spark SQL makes use of the following of the information about types to represent data efficiently. Spark SQL uses an in-memory columnar storage while caching data, which takes less space on being cached. And if data queries depend on subset of data, Spark SQL can minimize data read. This has to do with caching, as we mentioned before. So Spark SQL can move part of the query to the engine being queried with predicate pushdowns. To read only specific records in Spark, you can read the complete data set and then perform a filter on it. But with Spark SQL, if the data store allows recovering just subsets of the key range or any other constraints, Spark SQL can push the restrictions in the query to data store. Hence, less data is read and more efficiently. Okay. So performance tuning options. Okay, these are some lines of code that are used to tune the performance of our Spark SQL or of our Spark application basically. So first one we have here is spark.sql.codegen. So it has a default value. So what is happening is when you specify it, you specify spark.sql.codegen and you specify the value you want it to be equal to. So you run that before you start your implementation or your Spark or the other code or your queries you want to run. So what this does is as you can see the usage, if true, Spark SQL will compile each query to Java bytecode as it encounters, which can improve performance for large queries, but CodeGen can slow down short queries. So what it's saying here is that if you run this code and specify the value as true, Spark SQL will compile each query to Java bytecode. So if you convert to Java bytecode, it helps to improve performance. But however, what it does is it actually creates a background, or more like it starts running the compiler, the Java compiler from behind. So that could actually also take some time or slow down performance. So this is only advisable when you are running very large queries that could actually also take time. So if you want to improve their performance, you can use this as tool. But if you are running short queries that could run very swiftly and will not take time usually on SQL, you don't need to use this as tool, because if you use this as tool, it's going to slow those ones down, because it has to convert to Java bytecode and then start running a compiler, compiling the Java bytecode before it computes. So spark.sql.in-memory columnar storage compressed. So what this does is it compresses the in-memory column storage. So the storage of the RDDs in the in memory, basically the storage, the space available for storage. So it compresses that if you specify the value as true. So but default value is false as well. So yeah, so Spark SQL.in-memory columnar storage batch size. So what this is done is this is used to specify the batch size for columnar caching. So it's used to specify the number of row objects you can have in a particular columnar cache. So the number of row objects you can have. So remember that what Spark does is it splits your data set to store it in memory, splits it into RDDs and store it in various aspects of your memory. So you can now specify the highest number or the maximum number of rows that should exist in a particular storage or in a particular storage batch. So the value is 1000. So they said larger size may lead to out of memory issues. Reason being because the row object might be so large and the row might be very long. So if it exceeds, if the number of rows you now have are large and then the rows are very long, in essence, your memory space will be overloaded and lead to out of memory issues. So it's usually better to have smaller sizes. And then there's also okay, I think we'll go to that data now. So this one, the last one, packet, it specifies the compression codec to be used. Options include uncompressed, snappy, gzip. Okay, these are just codec formats to compress the file into the cache. So let me see. Okay, they didn't specify that. So okay, I think there's also a problem with the code gen. That's the third one actually. There's a problem with using very small this thing. So it says small batch size leads to low compression. So if you use very small batch sizes, you need to be having many batches or many packets of your data stored. So which is not advisable. You want to at least optimize. So when everything optimization will come in place. So it's better the default value that is set is 1000, and so you could probably just use the default when you have your data set to run. Yeah, so I think that brings us 8 points to remember to deal with this data set. Load data from has JSON, Hive. Okay, I think we've gone through all this. So Spark SQL has three main provisions. You can load data from a variety of structured sources. You can query data using SQL within a Spark program and from external tools such as Tableau for linking Spark SQL with usual database connectors. Integration using SQL and regular. So Spark SQL includes a special type of RDD called schema RDD. Okay, we've gone through that. To include Spark SQL in your application, you need some additional dependencies here. I think that's so. Yeah, so I think that brings us. We could say we are at the end of this. So yeah, I will stop it now. Thank you guys very much for.
Yeah, thank you. Please, can we give Mr. Ebube the round of applause? I want to hear our clapping. So good job, good job, good job. You really did a good job. And any question? Any question? Okay. No. Before we ask questions, so I would just like to chip in one or two things about Spark in general, and that is, I know we've learned about the in-memory capability of Spark, and there's an argument that Spark is faster than MapReduce. So how MapReduce works is MapReduce is not in memory. MapReduce speaks if MapReduce algorithm, if it's working on a particular data set or probably a particular block, after working on the block, before working on the block, it copies that block into memory. So when it copies the block into memory, it performs MapReduce job on it. The result, it writes it back to disk. So there's what I call the read and write operation in MapReduce. So moving from memory to disk, from memory to disk. But in terms of Spark only copies once from memory, from the disk, and copies to memory. Every other thing happens in the memory, and say even the communication with other nodes, everything works seamlessly on the memory end. And that's one thing about Spark that makes it simple to use, and especially talking about the speed and being able to work faster than MapReduce. So that's one thing I enjoy about Spark. And I was reading a material and they said, "Hey, very soon Spark will be the good to go guys when you talk about big data." So very soon you won't be able to talk about big data without talking about Spark algorithms. Yeah. So MapReduce, every one of us might understand MapReduce, but when you talk about application, Spark is always the good to go guy. So and let every one of us try research more about Spark in our various leisure time, how we can understand what really goes behind it. It's going to be interesting, and I know beyond we passing, I know we all are going to pass our exam. That's not a problem, but the problem is we being able to understand, and that is what I care for, and that's why we all need to add more research to what we are doing and to the class. So thank you everyone once again. So in case you have any question for the next 2 minutes before we call it a day. Okay, I guess there is no question.
So the
So
question,
oh yeah, Madam Esther.
yes, please. Can you please just probably explain further? I didn't really understand what he was talking about when he mentioned the Hive context and SQL context as the entry points for programming in Spark.
Okay, so the entry points. Okay. So to each programming language, there's what we call the entry point. Entry point is what is the first thing you do. Okay, let me out to try go to that page. Or if you everybody, please help me go to that page. So, but I'm going to explain offline. So the entry point is a point whereby each program starts. So when you're writing a Java script now, the entry point for Java is the function called main. Are you getting me? So, and that's the entry point for Java. So in terms of Spark too, Spark has its own entry point. I think there's an entry point for Spark that is called SC. So so that's the Spark connectivity. So that's also one of the main entry points for Spark. So is this the page? Okay, depending on when I blah 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 Spark query can be hype contest. Okay. Coming. Okay. So regarding to these that is the Spark SQL. So you should understand that Hive is a database, right? Yeah, Hive is it gives us a relational database field of the big data ecosystem. So it's possible when you are approaching Spark, you approach it in the Hive context. So let's see, say to provide access to HiveQL. So it's just like we being able to, we know HiveQL exists, and we'll talk about Hive query language, but it's just as if you want to make use of Spark, but you want to go through the Hive channel. So when you go through the Hive channel, it's just as if Spark is on top, Spark QL is on top, and Spark SQL is on top, and next below it is Hive QL. So it's possible you go through the Hive direction, whereby it's going to be an environment that looks similar to that of Hive, or you go directly to the SQL context. So which says it includes a subset of Spark QL support, which does not depend on Hive. So in this case now, the first part is dependent on Hive, but this in the SQL context is not dependent on Hive. So in case you have conflicts with including all of the Hive dependency. So now, so it's possible that maybe when you are working with Hive context and you're having issues with Hive dependency, but in this case now, you can sideline Hive absolutely when working with Spark. So whereby you work directly on your file, whereby everything you do it directly on your file, and all the query works on your file, not going through Hive and the like. So you can bypass Hive, but you can also go through Hive. Hive is like the closest channel to Spark that you can use to query your data. But anytime you have issue installing your dependency or probably other third-party software, you can work directly with the SQL context, which said is a subset of SQL support. So that's that.
Thank you, sir.
Okay. So thank you very much, everyone. I'm sorry. Today's class is short, though. Yes, it's not about the times about the knowledge we've learned. And thanks to Ebube once again for making yourself ready for the class and for sharing your knowledge. Thank you. So thank you, everyone. Please do also enjoy your weekend. Take time to rest. It's a weekend. I know you don't have class, so I know you have a lot of agenda for the weekend. But please try rest and chill out with friends and family. Visit one or two people and be fine before you come back on Monday. So but at least make your weekend a restful one. So thank you very much, everyone. Do have a blessed weekend.
Thank
And
you
you
very
too,
much.
sir. Thank
Very
you.
much, sir. It
You're
also have.
welcome.
Thank you to Tokoli. We really appreciate.
Thank God. Thank God. Bye.
Esther, Hubert, leave the class. It's over already.